So I want to talk about the surface of Mercury. We talked a little bit about the interior of Mercury, from what we can tell from the from orbit. One of the first views, this is actually a view from the Mariner 10 spacecraft that shows the surface features here, and there's a couple things you see in just this picture right here. You see craters, but you do notice something interesting. You see Kuiper crater right here of the great big rays, but you also see several of these craters here, and then like a ruined crater right there that got filled in almost like the seas on the moon. They got filled in, and they're smooth bottom. We call those smooth plains. So I'll get back to that because they are very analogous to the moon. And also right down in here, you see, kind of like this discontinuity, like a crack that is running across the surface of the planet right there. Okay, so there's several things in this picture I want you to take note of because we'll be talking about those. One of the big shocks when the Mariner 10 data came back was this enormous impact basin right here. So here's this mountain ranges right here that made up the edge of this giant impact basin. They called it the Caloris Basin right here. Now, only about 40% of it, we couldn't even see the center of it, about 35 to 40% of it, and was visible from Mariner 10, but you could obviously see the edge of it and see this thing was enormous. This is about big enough to put Texas in. And so this was, the idea you have a crater the size of Texas was just totally mind-blowing. It's near the subsolar point. Remember, Mercury, as it passes by the sun, it keeps one side facing towards the sun. That same side faces towards the sun every other Mercury orbit. That's the subsolar point there at perihelion, and this basin's right there. So Caloris means heat, so this is the basin of heat. So what's going on here? Well, when Messenger came by, it was able to see that it was even bigger than we thought. So that yellow dashed line is what they thought that it was going to be based on the Mariner 10 data. Messenger data shows the rest of that. It's a little bit bigger than they thought it was. Now notice several things here. It is smoother on the inside than it is outside. So this is like lava flows like the seas and the moon, except on the inside it's bright, not dark like the seas and the moon. Also, right in the center of it are cracks like that. Ignore that crater there. As far as we can tell, that crater just incidental, just stray, random impact. It just happened to be right near the middle of the Caloris Basin. But those cracks are actually indicative of something. So what's going on here? Well, we think that the Caloris Basin is in fact a giant impact. So we think that you've got this giant impact, cracked the crust, made this giant basin, the ground rebounded, and then as it solidified, it made it smooth, but because so much stuff had been blown away, the pressure for the interior kept pushing upwards and started cracking the surface right there. So that cracking is, we believe, rifting due to an uplift from the center being pushed upwards by pressure on the inside. Again, this suggests that Mercury is more tectonically active than is the moon. Exactly opposite the Caloris Basin is something that the Mariner 10 people looked at and said, that's weird. The ground is all jumbled and messed up and so forth, other than where craters have hit, and even some of the craters here, get jumbled and messed up, except where lava filled it in. There's a smooth plain right there, okay? But all of this is all smashed up, and the imaging scientists at the Jet Propulsion Laboratory, which is NASA Center, which handles all these interstellar probes, said that's weird. And so they proposed calling it the weird terrain. Well, the International Astronomical Union are really the only ones that name something, and the Committee on Naming was not very happy with the phrase weird terrain. And so he named it the hilly and lineated terrain. I personally like weird terrain. So what happened here? Well, what we believe happened is you got this giant impact on one side of Mercury. Shock waves went all the way through to the far side and through. It actually smashed all the way through with enough force to toss the far side upwards, hundreds of feet upwards before it came crashing back down. You imagine the kind of earthquake that would be. I guess Mercury quake. And so that is what was going on here to produce that weird terrain right there. Throwing all that stuff upward and big blocks of material crashing back down, making that jumbled appearance right there. The smooth plains. I said they're analogous to the seas on the moon. You get a big impact and then lava fills it in. Now, this is much the way things happen on the moon, on the seas, on the moon. The big difference is the seas on the moon are dark colored because magma on the interior of the moon, the basaltic stuff there is darker in color. That should be true on Mercury too, so something else is going on. When we do mineral studies, we find that, yeah, these smooth plains are a little bit more rich in iron, kind of like we expected. But it also is indicative that there's other places on Mercury where there were iron flows. And so some of the places where you had iron flows were darker in color, but the smooth plains were lighter in color. So that suggests that you have ancient volcanic activity on Mercury, maybe more than we expected, which made some of these darker colored things. But the cracks that filled in the low regions were lighter colored iron deposits. And so that means it's a different chemistry involved. So what does this mean? Well, again, we see when we look at Mercury, we see, for example, this bright region up here is at that's not a crater there. That's not an impact crater. The shape is all wrong. For that to be an impact crater, that's a volcanic crater. And the stuff spread around it is from like explosive sort of release. This is kind of, like explosive or volcanic release. Again, this suggests that Mercury has had substantially more volcanic activity than the moon. It does not mean it's as volcanically active as Earth, but it's vastly more volcanically active than the moon. Again, this goes along with the interior not being completely solidified. Something is keeping the interior liquefied. Okay. The volcanism here is weird. There is an evidence that there are different kinds of volcanic activity. Again, we have some dark-colored basalts. We have some light-colored basalts. The smooth plains are mostly light-colored basalts. Again, that volcanic vent right there seems to have light-colored basalts around it. So how do you get light-colored basalt? That's not at all what we find on the moon. That's not what we find on Earth. Okay, now I say it's not what we find on Earth. Now, when we are in person, and we're doing this, I bring in some rocks as demos here, and we pass them around the class, we look at them, and I go to the geology lab and I get some of the dark colored basalts. Now, if you really rummage through the rocks that are in the geology lab, you can find a few light colored basalts. Those are basalts that have other chemicals mixed in with them. For example, if you contaminate your basalt with sufficient sulfur, it makes the basalt lighter in colored. So that would suggest that Mercury may have a contamination of an excess amount of sulfur in it. Not just somewhat sulfurous, but sulfur on a planetary scale. That would make the chemistry of Mercury somewhat unique in the solar system.